Hello, and thanks for tuning in. Today's topic is entitled Reducing Alarms in regards to ferromagnetic detecting systems. This talk is being sponsored by Metrasens as part of 2021 MRI Safety Week. My name's Alan Heffron. I'm an MRI safety trainer for Metrasens. And what I'd like to discuss with you today is the importance of reducing alarm fatigue with these ferromagnetic detector systems. A little bit about myself. I'm an MRI technologist. I came up through the ranks as a radiographer, worked in CT. I'm also a certified radiology administrator, as well as an MRI safety officer certified by the American Board of MRI Safety. So what is alarm fatigue? Alarm fatigue occurs when someone is exposed to a large number of frequent alarms and consequently becomes desensitized to them. Now, this can be problematic because folks start disregarding important alarms. Now, alarm fatigue has been recognized as a Joint Commission several years ago as a point of emphasis to make sure that hospitals do everything that they are able to make sure that the electronic alerts that we hear are meaningful. So a couple of definitions. We have false alarms versus extraneous alarms. Now, a false alarm is triggered when there's no ferrous object passing through the detector, but an alarm occurs. Now, that can occur when someone who is ferrous-free is passing through the detector and the detector senses, say, like a moving office chair or some other significant ferrous object while the person is passing through. So that's considered a false alarm or a false alert. An extraneous alarm is when a ferrous object is passing through a detector deliberately. Perception may be that this thing that I'm wearing or this thing that I'm carrying, even though it's ferrous, is safe to enter the room. It's not going to be a missile effect. One of the issues with doing that is that when we become desensitized to that, then when we do have something that is ferrous on us, then we tend to disregard that. So a quick history on ferromagnetic detector systems. They were developed in response to the Michael Colombini incident, in which the 6-year-old boy was killed in an MRI by an oxygen cylinder that was introduced into the room. They're produced by several manufacturers, of which Metrasens is one. They use detectors capable of detecting only ferrous elements. So that's all we're interested in is ferrous objects, things that are going to be a potential missile in the room. And they differ from airport metal detectors in that they only detect ferrous objects, where an airport metal detector will detect all types of metal. They're available for zone 4 entries, which is depicted in the image on the PowerPoint. And they're also available for screening patients and staff prior to entry into zone 3. Now, these are typically sited in zone 2, and these don't have as much issue with alarm fatigue as the door entry systems. So why do we need them? Well, to keep bad things from occurring in our MRI rooms. It reduces risk. It increases MRI safety and gives you increased confidence that you will not be injured on the job. Also, if none of those reasons appeal to you, there's always the you won't have to fill as many incident reports out reason. So how do they work? So there's many different types of ferrous metal detection systems, FMDS, but they all essentially do the same job. They may do them a little bit differently, more or less effectively, but essentially what they are designed to do is detect changes in the ambient magnetic field. So the Earth has its own magnetic field. Everything in your room that has power to it has a little bit of an electromagnetic field. And as long as those things are stable and not changing, then the ferrous metal detection systems, the FMDS, will ignore them. So they won't do anything. But when you introduce an object that's ferrous into that environment, when it gets close enough to the detector where it can be seen, if you will, by the detector, then it causes a change. And this becomes our sixth sense. Human beings don't have the ability to detect magnetic fields, but we have these tools available to us that can detect the systems, or detect the ferromagnetic objects for us and alert us both visually and audibly. So how have they improved over time? Now, the early systems suffered from a great deal of alarm fatigue. Uh, they were essentially two poles that hung on the wall, but each time you opened the door to zone 4, they would alert because there's ferrous material in the door. Um, and every time you close the door, it would alert. Every time you walk by them, they would alert. So some refinements were made, and one of them is motion detection technology. Now, the reason that's important is that it enabled the system to only detect threats that are going into the room. And by that, I mean it can sense the direction of travel. So if you're carrying a pair of scissors into zone 4, the system sees that, and when you cross that threshold, it will alert you audibly that you have a potential threat. Now, when you turn around with that same pair of scissors and walk out, then you will get a visual alert, but you won't get an audible alert. The ability to disregard the zone 4 door was critical. We needed some way for the system to ignore that zone 4 door detection. And Metrasens deployed an electronic eye that sees that door. The systems are now much more customizable. And by that, I mean you can change the detection level at install to look for different items. If you're looking for something with a magnetic signature, say of a cell phone, we can set it for that. If you're looking for something that has a greater magnetic signature, such as a pair of scissors, we can set it for that. So we can reduce the number of smaller alerts by changing the detection capabilities of the system. View technology. View technology stands for visual early warning. And what that does for us is it gives us a heads up sooner if you have a greater magnetic signature than a smaller item. So say if you're wheeling an office chair towards the MRI room, you will see a visual cue that the object that you are moving is ferrous. Whereas a smaller object, it would react a little bit closer to the doorway. Alert management systems have been instituted. Now, the way an alert management system operates is it is a technologist selectable device. You simply press a button, and if you know you're bringing an object such as a detachable table or an object such as a ferrous wheelchair that is MRI compatible, then you can ignore that alert for a set period of time, and then the system will automatically reset. So how do we get the most value out of these systems? Well, it's important that we reduce these extraneous alarms. So the manufacturers have gone to great lengths to engineer solutions to alarm fatigue. But it's incumbent on us as a technologist to also play a role in that. So how do we reduce these extraneous alarms? Well, we increase the effectiveness of the system. So what we do by that is we don't wear ferrous objects that we don't need to be wearing. If we can get away with a non-ferrous solution, and that will result in fewer audible alerts, then that's important. We want the alerts to be meaningful. We want people to react to them appropriately. Most causes of extraneous alerts are preventable. We could have worn this instead of that, or used this object instead of that object. So the idea is to keep the alerts meaningful and react appropriately to them. And of course, if there is an issue with the system, that it's reported to the manufacturer's service team so it can be remedied. So that if there are alerts that are extraneous being caused from malfunction in the system, that those are remedied quickly. So how do we best deploy the system? So we introduce systematic adjustments. Ferrous detection systems are not a plug-and-play solution. We also need to make some adaptations to the way we work, maybe the way we dress, and we need to incorporate that into our daily work habits. We may enter the room differently if we are wearing ferrous objects. We may enter the room first, wait for the alert to clear, and then invite the patient or staff member into the room. Remember that the FMDS is only one aspect of the safety program. It's not a standalone solution. It's meant to be used in conjunction with your existing protocols. It's an adjunct to what we do today. Won't replace anything that we're doing today. We follow best practices. So best practices include using non-ferrous solutions whenever possible. And that includes wearing ferrous-free clothing, ferrous-free shoes. We eliminate the extraneous ferrous items, Fitbits, watches, things that in reality may not be a missile effect threat. However, they contribute to extraneous alerts. So it's important to note that even though what you may be wearing, you can get away with it in the MRI room in terms of safety from a missile effect standpoint. But it's important to note that these things may be causing you to have an alert each time you open the room and at each time you enter the room. And we want to make sure that the alerts that we hear are meaningful. So we can replace common items with ferrous-free options. And some of these common items are badge reels, lanyards, and different solutions that have come about in the last few years that enable us to still use our badge access without having to take our badge on and off. And they're quite reliable and easily available. We work to make the alerts meaningful and react to them appropriately. And another important thing is the availability of ferrous-free transport equipment. Now, there's lots of MRI conditional and wheelchairs and MRI conditional stretchers that are out there that do have enough ferrous content that they will trigger an alert on the system. Now, they're safe in the manner that they don't have enough mass that they will be propelled towards the magnet, but they do contain some ferrous material. Okay, we're going to implement all those solutions. It sounds great, but it ain't going to work here. So I travel. continuously and train people throughout the United States. And I hear a lot of reasons why this won't work here. And here are some of them. And here are some of the reasons. Humans have an inherent resistance to change. There's an old saying that everybody likes progress, but nobody likes change. And that's true. And I fall into that category too. So we need to rethink how we do things. We need to be willing to adapt to different procedures, maybe the way we dress, maybe what we wear in terms of jewelry, watches, so forth. And there are solutions out there. One of the solutions we came up with for a facility that needed timekeeping is we simply put a digital clock in the window of the control room that can be seen from the MRI room. So there's solutions out there for almost everything. That's the way we've always done it. Well, that's one of the worst reasons I've heard not to change. That's the way we've always done it. And also, this is a bit of a challenge to the MRI technologists, and I include myself in that, is what do we value? Do we value MRI safety? Do we value risk management versus comfort, or vanity, or convenience? So that's a challenge. What do we value? Now, all that being said, can we still get value out of these systems without changing what we do? Absolutely, yes. And let me give you an example of that. You can imagine that you are working at the magnet, you have your back to the door, you're setting up a patient, or you are putting a coil on the table, you're cleaning something, and you hear this alert behind you. You hear an audible alert. Now you have information you didn't have previously, and you can turn and react to it and be ready to stop someone that may be entering the wrong way or bringing an object in there that may be dangerous. So it's important when you hear those alerts that they are meaningful and that you react appropriate to them. So in conclusion, the manufacturers have engineered some solutions to combat alarm fatigue. They're not perfect. No ferrous metal detection system is perfect. However, we as the technologists, we need to share a role in the solution if we are going to maximize the use of the system. I'd like to thank you for tuning in today, and keep in mind that all of our Safety Week videos will be available on the Metrasens website at metrasens.com. Now, those of you who'd like to continue this discussion, I can be reached at the email address on your screen, and my cell number is there as well. I'd be happy to discuss this further. Thank you for tuning in, and have a great MRI Safety Week.